Hello, today's lesson is on a measure of center that we call the mean. It's section 9.2 in your Big Ideas textbook. The essential question is, how can you find an average value of a data set? So the first thing I want you to think about is what are some examples of averages that we use, right? So you can pause for a minute and see if you can come up with some ideas on your own. And then I'll show you, well, your grades, right? So the PowerSchool gradebook that we use automatically averages all of your assignments together, and every time a new assignment is added in, it recalculates your grade. So grades are the average of if they're in a test category or a homework category, or maybe they're all lumped in together and you're just looking at points and it's taking the average number of points that you got. So there's a batting average, right? Baseball season is starting, and the statistics that are kept on baseball players, one of the statistics is their batting average. And then you could look at weight. And maybe you're looking at the average weight of people on a ride, right? Because there's some kind of a weight limit, or like on elevators, if you ever go into an elevator and it says the maximum weight limit in an elevator, that could be, you're looking for an average weight. Height, right? We could look at the average height of an American, maybe a boy versus girl, let's see, a high schooler versus a middle schooler, probably a different average height. And then annual rainfall, we could look at averages. I don't know if you know that San Diego gets about 8 inches, in an average of 8 inches a year, but not always. And then income, and there's a lot of statistics out there about average income. And in fact, the more education you have, the more likely that your income average is higher. And here's the slide where you see the red stars. So you are writing this down in your graphing notebook. This is also in your textbook on page 398. But a mean is a type of average. And we'll be looking at some other types. But for now, please write in the word average. And then the mean, right, which is like an average, the mean of a data set is the sum of the data divided by the number of data values. So if, for example, you have a data set that has 8, 5, 6, and 9, there are 4 data values. So you add up all of those numbers and you divide by 4. So the average of this data set is 7. And let's say it had to do with how much rain you had in a city, right? If it rains 8 inches, 5 inches, 6 inches, and 9 inches, we would say that the average rainfall was 7 inches because we took the numbers, we added them together, and then it's basically a fair share idea. And we are saying, well, what if all of the 4 days were equal? They would all have to equal 7. And then I'm asking you, what does the mean really mean? And so here's what I want you to write down. One value, there is one value that could represent all of the data. So this 7 is representative of this data set, even though the numbers are not all 7. We could think about, well, if I was going to pick one number that best represents, for instance, how much rain there was in 4 days, I would pick the 7 because it's an average, which also is the same idea if all of the data were the same. So if every day was a 7, that represents the 8 plus 5 plus 6 plus 9 divided by 4. So here's an example of how you find the mean, right? So here's a table that shows the number of text messages that was sent by a group of friends over 1 week. And if I'm asking you what the mean number of messages sent is, whenever you see the word mean, right, you're thinking, hey, it's an average, right? So if I kind of want to know how many texts per week these friends send, well, I'm going to add up all the number of text messages. So this is how you show your work, even though you are using a calculator, right? 101 plus 125 plus 82 And I want you to write all the numbers down just so that your brain understands what's happening. I don't want you to pick up a calculator and start adding those numbers together, because if you make a mistake, I will not know where your mistake came from. So please write out all of the numbers. And now I have to, they are going to be divided by 7. But of course, first I do the adding. When I add up the top row, I get 721 text messages between 7 people. And when I do the math of 721 divided by 7, I get 103 messages, right? So that's the mean number of messages. It's what we call an average. Okay, so here's an OYO, right? These are on page 399 in your textbook. I'm asking you to pause this and find the mean of each data set. And then I'll show you my steps along the way, right? So the first thing I do is add up all the numbers and divide by how many numbers there are. And usually what I do is I count and I cross them off after I write them down, right? Or I just count again, 1, 2, 3, 4, 5, 6, 7, 8, to make sure I'm dividing by the correct number. So you get 456 divided by 8. The average of that, the mean or the average is 57. And then go ahead and pause the video and try the next one, right? Decimals aren't any different. It's just that they're decimal numbers that you have to be careful when you enter them into the calculator. So there's all my account, right? Oops. Let's go back to that. One more, and I'm going to count 1, 2, 3, 4, 5. Make sure I'm dividing by the correct number. And I get 37.5 divided by 5. So the mean of that data set is 7.5. Now, when you're looking at the numbers, right, you know how we say that when you look at your answers, you should say, does that make sense? And so when I look at this data set, here's what I'm doing, kind of just eyeballing it. I see a 70 and I see what's the lowest number? So I usually look at the highest number and the lowest number. I see a 70 and I see a 49. Okay. So I think it kind of makes sense that 57 is the mean for this data set. There's a lot of numbers in the 50s. And then if I look at this data set, it goes from 8.5 down to 6.7. And then my answer of 7.5 is somewhere in between those. And that seems reasonable too, right? So even if you're using a calculator, you want to check and make sure your answer is reasonable. Okay, and now we are on to another red star. And this is pointing out something very important that can actually have a big effect on a data set. It's called an outlier. An outlier is a data value that is much greater or much less than the other values. When included in a data set, it can affect the mean. Now, there's a mathematical way to figure out if a number really is an outlier, but we're just going to keep it simple and try to figure out if there is one number that seems much lower or much bigger than the other numbers. We are going to identify that as an outlier. Just again, kind of using a little bit of logic and common sense. We're not going to make it too mathematical, but we can. And so this idea is I want you to find the mean with the outlier and without the outlier. So for example, 3, first we're going to look at the data set, right? There's these cute little Shetland ponies, and this is how tall they are in inches. Those are small horses, well, ponies. And so if I look at the data, I see 40, right? This is in the high 30s and the 40s. There's more high 30s. And then, ooh, I see a 28. Okay, that's way smaller than the other numbers. So I'm going to say, for this example, it looks like the 28 is an outlier, right? It's very different from the other numbers. So the first thing I do is identify the outlier. Now, I want to find the mean with and without the outlier. So the first thing I do is I go through and I think about how many numbers I'm going to be counting, right? So I look at this table and I notice that there's 1, 2, 3, 4, 5. There's 2 rows of 5. So for this, where I'm including the outlier, I'm making a note that I'm going to divide by 10 because there's 10 numbers. And then when I throw away the outlier, I won't have 10 numbers anymore. I'll have 9. So without that outlier, I'm making a note that for this data set, I'm dividing by 9 because I don't want to make that mistake when I start adding all the numbers. Okay, so now I'm going to do the math of the mean with the outlier. So I need to add all of these numbers. All right, so here we go. There's a lot of numbers to add. So I have the 40 plus 37 plus 39 plus 40 plus 42 plus 38 plus 38. I'm going to do another row here, plus 37 plus 28. I'm going to circle that one because I'm going to remember that that is the outlier. Okay, when I add up all those numbers on my calculator, I get 379. So I get 379, and I'm dividing by 10. Now remember, when we divide by powers of 10, you can use your calculator, but you can also think about moving the decimal over one place. So this is 37.9. So now the average the average height of these Shetland ponies is 37.9 inches. Now I'm going to find the mean without the outlier. Now here's an easy thing that you can do. You can add up all the numbers, not including the 28. I was thinking that maybe you guys get this idea. If I have 379, because I've already added all those numbers, I could just subtract the 28, right? Because that's the outlier that I'm getting rid of. So I just thought I would show you that you don't have to add up all the numbers again. If you're confident that your first, the sum of all of those numbers is correct. Okay, so I got 351, and then remember this time I'm dividing by 9. So I get 39 inches. So for this example, it's 39 inches. Okay, so now I want you to notice what happened. So the outlier was a number that was smaller than all of the other heights. So when I include this 28 and divide by 10, I got 37.9. And when I throw away the 28, I get 39 inches. And I want you to see that the 39 makes more sense because it is right in the middle of the 37 and the 40 and the 42. So the mean without the outlier totally makes more sense. And I'm going to show you on a dot plot so you can see visually what it looks like. So I'm going to move my little pony guy over, and I'm going to erase all the math that I did so that you can see this line plot here. Okay, so, oops, did I move some of the dots from the line plot? I think I did. Okay, so let's go ahead and add the 42 and the 40 and another 40. Okay, so there's my line plot, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Uh-oh, I missed another number. There was 2, 38, 39. Oh, sorry, there's 3 40s. Okay, now I have 10 data plots back on my dot plot. Okay, so what we figured out was the mean with the outlier is right here, right? 37.9, almost 38. That's about where that is. And the mean without the outlier is a little bit higher, right? It's at 39. Now, it does make more sense to use the 39 because when you look at the picture of where all the dots are, they seem to be from 37 to 42, right? So this 39 is somewhere right in the middle of all of our data. So what happens is this outlier, because it's so much lower, it actually shifts the mean, right? So instead of a 39 average, it looks like the average would be 37.9. And that's not really representative of the data. So now we just answered the A and the B on this, and we're going to look at one more question that we won't have when there is an outlier thrown into a data set. Okay, so the thing that we really want to look at is describe how the outlier affects the mean, right? And I just showed you that the mean, oops, let's not do that. Let's grab this. The mean with the outlier was right here, okay? And the mean without the outlier was here at 39. And this just makes more sense because it seems to represent the data better. So here's what I'm going to tell you. the outlier, this outlier lowered the mean because the outlier itself was so much lower than all the data points. With the outlier, the mean is less, and now it says it's less than all but 3. So what they're trying to show you is that that this mean is only bigger than these two plus that one. So there's only 3 data points on the left side, and then look how many there are on the right. 1, 2, 3, 4, 5, 6, 7, right? So there's 3 points on the left and 7 on the right. So it definitely doesn't seem very representative. Without the outlier, the mean better represents the heights, right? So now we get to start making choices about our strategy. If the outlier changes the data and it doesn't represent what's happening, it makes sense not to use it. Okay, next we're getting to an OYO. So this is for you, right? So I'm going to ask you to do 3 things. I'm going to ask you to identify the outlier, find the mean with and without the outlier, and then describe how the outlier affects the mean. So go ahead and pause the video, and then I will go through and show you the answers. Now, one of the things I want to point out is these 2 examples have an outlier that is smaller, but an outlier, just remember, keep in mind that it can be much larger than the other numbers in the data set. Okay, so I looked through this. I count 1, 2, 3, 4, 5, 6, 7. So I've got 7 numbers. So I know with the outlier, I'm going to divide by 7. And then when I, cross off the outlier, I know I'm going to be dividing by 6. Again, that's just a little note I make for myself. So I make sure I divide by the correct number. And then I look at this data set and I see, whoa, so the highest number is 60 and the lowest number is 8. And then, when I go backwards from 60, 55, 50s, 48, there's a big difference between 48 and 37, but there's an even bigger difference from 37 to 8. So 8 definitely seems like the outlier in this data set. So now I'm going to calculate the mean with the outlier. So I add my 48 plus 50 plus 55 plus 60 plus 8. I'm going to circle it to remind myself that it's the outlier, plus 37 plus 50. And then I'm going to divide all of that by 7. So when I do the math on my calculator, I get 308 divided by 7, which equals 44. So the weight of these dogs at a kennel, the mean weight, which is like an average, is 44 pounds. Now I'm going to find the mean without the outlier. Now remember that trick that I taught you? Right, you could just do this, 308 minus 8. So if I add up all those numbers, it adds up to 300, and then I'm going to divide by 6. And I get 50, and remember it's pounds. So the mean weight without the outlier is 50. So when I ask you to describe how the outlier affects the mean, I hope you're seeing that the outlier lowers the mean. And it's not really representative because if I look at an average of 44, here's what I would do. I would want to count like how many dogs are less than 44 and how many are more, right? So I like to do a dot plot, but if I'm not doing a dot plot, I could just circle, let's see, in red, I'll do how many are less than 44. There's 2 less than 44, and then I'm going to circle in blue the ones that are greater than 44, right? And so now you can see this is where it starts getting interesting. There's 5 values that are greater than 44, and there's only 2 that are less. So it seems like maybe that's not a great representation of the average weight of the dogs. And then the mean without the outlier, this one makes more sense. In fact, there are 2 dogs that weigh 50. That's maybe a coincidence, but there are, if I look at the 50 as my middle point, then there is, let's see, 2 dogs above and 3, well, without the outlier, there's two numbers above 50 and 2 numbers below 50. So that seems more like a fair share. Okay, so now I am going to make sure you pause the video and come up with in your own words, describe how the outlier affects the mean. And I will show you, oops, not there, it's here. Okay, so the outlier makes the mean less than all but 2 weights. But the way that I like to say it is more like this. The outlier makes the mean lower, right? It really does lower it. So it makes it lower. And then I would say it is less than most of the weights. That's how I was going to word it. So 44 turns out to be less than most of the weights, so it's not very representative of the average weight of the dogs. So this outlier lowers the mean, and so if we were going to try to calculate the mean, we probably would throw the outlier out and call the mean 50 pounds. And that's it. That's your lesson on finding the mean of a data set.